Morning all. Today we are going to discuss about the fifth module of optical communication, that is optical amplifiers. As an electronics and communication engineering students, I think all of you familiar with amplifiers. The amplifiers are those circuit which is used to strengthen the weak signal. Here also the amplification purpose is saying we have to amplify or strengthen the optical signal. Okay, it is a device that amplifies an optical signal directly without the need to first convert it into an electrical signal. That is, here we are using optical amplifiers to amplify the optical signal. So instead of optical amplifiers, we are using the electrical amplifiers. Firstly, we should convert the optical signal into electrical form. Then, in this electrical form, we have to perform the amplification, and after the amplification, we need to convert again into electrical signals. So, these processes are replaced by using the optical amplifiers. Okay, it can be placed anywhere on optical length to provide the amplification. That is, these amplifiers can be placed during the transmission line or prior to the front end of the receiver or anywhere. All these things we will discuss soon. So optical amplifiers are bidirectional and optical multiplexing is also possible. That is, optical amplifiers accept many signals of different wavelengths and provide amplification. That's why they are bidirectional and optical multiplexing is also possible here. As I mentioned earlier, these optical amplifier can be placed anywhere on the optical length to provide amplification. Here you can see the first one, inline optical amplifiers. In this case, these optical amplifiers are placed in between the optical transmitter and optical receiver. It can be used to compensate for transmission loss and to increase the distance between the transmitter and receiver. Here in this figure, you can see there is optical amplifier or inline amplifiers are placed in between the optical transmitter and optical receiver. That means these amplifiers were placed in the transmission path or the communication channel or the optical fiber channel. That is, during the transmission that may undergo many losses and distortions, noise affection, etc. So by implementing or by introducing this type of inline amplifiers in between optical transmitters and the optical receivers, uh, we can compensate for the transmission losses, and also we can increase the distance between the transmitter and receiver by introducing this type of amplifiers in the channel. Next one is pre-amplifiers. So I think all of you familiar with receivers, various type of receivers. Almost all receivers, the front end of the all receivers, that may be a pre-amplifier. Before going to the receiver sections operation, that is demodulation and such operations, first we need to amplify that signal. The signal that is transmitted from the transmitter, while it reaches to the receiver section, that may undergo many distortion or many noises and they be attenuated by using many factors. Okay, and so that we need to amplify those signals before going to the receiver section operation. So it can be used as a front end of pre-amplifier for the optical receiver also. So if you are placing that optical amplifier in the front end of the receiver, we can call it as pre-amplifiers. So a weak signal is amplified before photo detection so that the signal to noise ratio is improved. At the receiver, due to the suppression of the noise, it is to improve the sensitivity of the receiver also. Okay. Another type is a power amplifier or the transmitter boost amplifier. That is actually the post amplifier. In the figure, you can see that these optical amplifiers are placed just immediately after the optical transmitter and before entering to the optical communication link or channel. Okay, that is just before the just before entering into the communication channel, that is power or power booster or booster amplifier or transmitter amplifier. These amplifiers are placing immediately after an optical transmitter to boost the transmitted power. So it's also called as a post amplifier. So these things were discussed where the optical amplifiers were used. So we were discussed about the optical amplifiers. So what are the purpose of the optical amplifiers? In which cases or which position in the optical communication path, in the transmission path, that inline amplifier, we can use the optical amplifiers in between the transmitter and receiver, or the front end of the receiver, or the post transmitter amplifier, or these ways we can use the optical amplifiers in optical communication. And there are different types of optical amplifiers. There are the important types of optical amplifiers shown here. That is, first one is semiconductor optical amplifiers, SOIs, and active fiber or doped fiber amplifiers, that is DFS, and Raman amplifiers. Then now we are going to discuss about the basic operation of a generic optical amplifier. Okay. In figure, you can see that optical input signal, that is connected to or coupled to the optical amplifier through fiber to amplifier couplers. The main part of the main portion of the optical amplifier is nothing but there is an active medium and a pump source. From this pump source, energy is supplied to the active medium, and the amplification process is taking place in the active medium. And this optical amplifier again couples to the fiber by through fiber to optical amplifier couplers, and after that we get an amplified optical signal. So the device absorbs energy supplied from an external source, that is called a pump or a pump source. The pump supplies energy to electrons in the active medium, which raises them to higher energy levels called population inversion. I think all of you know about the population inversion. You were studied in the working principle of the laser. An incoming signal photon will trigger these excited electrons that drop to lower level through a stimulated emission process. The stimulated emission process, it is depends on the population inversion. I think you know that how the stimulated emission is occurring, and what is the purpose or essentiality of the population inversions for obtaining the stimulated emission, etc. Since one incoming trigger photon stimulates the cascade effect, in which many excited electrons emits photons of equal energy as a drop to the ground state. This results in amplified optical signal. We get an output. This is the amplification mechanism that is in semiconductor optical amplifiers and doped fiber amplifiers. So the working of the principle of the amplification mechanism of Raman amplifier is slightly different from this. But in Raman amplifiers, there is a transfer of optical power from high power pump wavelength to light wave signals at longer wavelengths. That is actually the this Raman amplification is done without population inversion. Whereas in semiconductor optical amplifiers and the doped fiber amplifiers their amplification is done with the population inversion and stimulated